In this video, I want to talk about a field called learning analytics, which are the techniques that are actually used to analyze the data in schools. So learning analytics is the measurement, collection, analysis, and reporting of data about learners and their context for purposes of understanding and optimizing learning and the environments in which it occurs. And this comes from the Society for Learning Analytics Research. There are several techniques that can be used to bring meaningful insights from learning data. The first set of techniques is prediction modeling, which is used to infer some unknown information based on the information that is available. Examples include whether a student will pass a course, if the student is meaningfully engaged in an online course, if a student is on track to graduate, how well the student will retain the learning that's going on into the future. Within prediction modeling, there are also two types. The first is classification, which predicts which category applies to the situation, such as will pass or will not pass, and regression, which tries to predict a specific value in a range, such as a grade. Another useful technique is latent knowledge estimation, which tries to predict how well a student actually understands a concept based on past attempts. The idea behind this is that a measurement by itself, on an assessment isn't really a 100% accurate measurement of how well the student understands the concept. So this technique is used to try to take several pieces of data together to determine how well does the student understand something. Another very useful group of techniques is called structure discovery, which is used when the analyst is merely trying to discover underlying patterns that are not yet known. So maybe the researcher or the administrator, the teacher, whoever is doing this, doesn't exactly know what it is that they're looking for, but they just want to pull out some kind of pattern in some kind of trend that's from the data. There are several specific techniques that make up structure discovery. Clustering is used to define groups of students or data points based on similarities in the data. One that applies well to online courses is social network analysis, which analyzes the interactions between students, say in a discussion board. Another set of techniques is relationship mining, which tries to identify correlation and causation between data points. One final technique that is extremely useful is visualization, which simply presents the data in a visual format that a human can study to try to find insightful patterns. So I have this case study that I wanted to do with a technique called K-means clustering, which is one of the learning analytics techniques that were just talked about. So the idea with this case study that I'm going to go into is trying to create small groups using testing data. All right, now K-means clustering is an algorithm that identifies boundaries between K numbers of groups. So let's say you have 30 students in a classroom, but you would like to break them into 5 different groups. And these would be homogeneous groups where they share some kind of trait in common, but you would try to break that group of 30 students into 5 groups of 6 students. Ideally, it might not exactly work out that way, but you would be trying to make 5 different groups. And it would make these groups in with that data set by analyzing the similarities and the differences. So if you took all the data points, if it was just a two-dimensional screen where you just had one side on the horizontal axis and another side on the vertical axis, then that would be fairly easy for a human to do, where you could just look at it and you could find the different groups there. But it becomes much more difficult when you try to get into many more dimensions, more than just two, which most data sets are more than just 2 dimensions that you're trying to find some kind of a pattern with. So to do this kind of a process, because it is not exactly an easy process, there's the ML5JS library from ml5js.org, which provides an easy JavaScript interface for many artificial intelligence algorithms, which this is one of those, such as this K-means clustering algorithm. So here's an example of a data set. What if you did a formative assessment and it only had 10 questions on it? It's not even that big of a data set. But even with those 10 questions, that gives you 10 different dimensions that a human definitely could not comprehend what a graph of that would look like, and could not easily pull out any trends by looking at a visualization of this. And it would only be 10 dimensions if we merely wanted to know whether the student got the question right or wrong. What if it was a multiple choice and there were 5 different options for each of those questions? That would actually be 50 different dimensions that we would try to pull an inference from. This is, again, something humans really couldn't do by looking at a graph, but computers can calculate the distance between those points, even in 50 different dimensions. So the idea behind this technique would be that I wouldn't just be trying to break the students into groups based on how well they did on average on this assessment. That I would actually want to put them into groups based on the individual concepts that they either collectively didn't understand very well or they did understand well. That I would try to break them into groups based on those individual questions and individual concepts, not just the one final average, which maybe isn't giving us the best picture. So the example would be in this screen here. So what I did was I loaded in some fake data from a quiz. So this is what the raw data looks like for the different questions. So I don't have any student names here, and they're just randomly generated information. But for the 10 different questions, then, these numbers just indicate whether they got it right or wrong. So I'm only dealing with the true or false with these 10 dimensions here, but for each of the students, right, for the 17 students in this data set. So I'm using the ML5 library along with this P5 JS library, which makes just doing visualizations a little bit easier in JavaScript. But the key part here is using this ML5 library, which allows me to do many different artificial intelligence algorithms fairly easily with some pretty simple JavaScript. And a lot of the code that I have here is really just about the little picture that I'm drawing. So this algorithm, the Kmeans algorithm by itself is very useful, and the ML5 library makes it pretty easy, with somebody with some programming experience to use an algorithm like that, and to also use many other artificial intelligence algorithms like neural networks that are very, very powerful at making predictions. So when I run the program here, it uses the K-means algorithm to look at all of those data points in those 10 dimensions and tries to group the students together based on the specific questions that they either missed or got right. So the result is this kind of a grouping here. The colors don't really represent anything other than it's for a different group. I do think that I could improve on the visual experience here as far as how a teacher looking at this would interact with this summary, but it gives us a pretty good idea of how the analysis done with this technique could be used to put students into different groups. And again, it's not just based on their average, it's based on the questions individually that they got right or wrong. And the same information is just shown in text here. So it tells me for group 1 that student number 2, which could have a name here if I wasn't hiding the names, but group 1 contains student number 2. Group 1 also contains student number 10. Group 1 also contains student number 14. Group 1 contains student number 15. Group 1 contains student number 16. Group 1 contains student number 17. So the teacher can look at this and decide which students need to be in this group together. And you see how the next one shows group 1. Student 1 is assigned to that group. And then also in group 2 is student 3. In addition, I got the information for which questions that they missed. One thing that I can improve about this is to try to aggregate it together for each group. to show that, okay, in this group, 80% of students missed these questions. But at least in this format, that a teacher could still look to see the common questions that were involved here. If student 2 is representative of group 1, then we know that these questions are going to be something to take a look at. As I scroll through the different groups here, then that information changes as far as which questions they missed and who's involved in it. So you can see in group 4, for example, there really aren't a lot of examples of questions that they missed. Maybe there were a couple, so that could be a good conversation for this group to still talk about. But you can see the similarities between the questions that they made. And this also shows that there's this one student here that was placed into group 3 that was kind of all by themselves as far as the questions that they missed or not. There wasn't a ton of connection with any other grouping of students, which would be valuable to know that that's the way that they understood the content there. So these groups that are ideal based on the questions they got right or wrong, those could be slightly adjusted when you go to actually put students into these groups. But this is just an example of how this technique could be used. So I could see a platform like this being created, improved for the interface and how the data is loaded in and presented. But then teachers could plug in their results from a quiz or a formative assessment, and then get this set of groupings. So this is just one of those more advanced data analysis techniques that could be used to help students in the classroom.